ball that isn't the sun. But could the Jovian system harbour humanity's future home? What's the deal with the big red spot, which is literally scientifically known as the big red spot? And what do you think I had to search to get this? Because I'll never tell. 2 out of 3 of those questions are going to be answered, so prepare for liftoff and a few years of dull space travel as we travel to a behemoth of a planet with 101 facts about Jupiter. Number 1. The planet Jupiter is the 5th planet from our Sun at the centre of our solar system. You remember that thing we all learned at school, right? My very easy method just speeds up naming planets. Well, the just bit, that's Jups. Number 2. Jupiter is believed to have formed at the same time as the rest of the solar system, making Jupiter approximately 4.6 billion years old. Apply for that bus pass, mate. Number 3. It's thought that Jupiter was formed at or beyond what is called the snow line or frost line, which is a hypothetical line where the distance from the sun is great enough that the temperature is so low that volatile chemical compounds like water, ammonia and carbon dioxide condense into solids. Yep, if you like that, strap in. Loads more science to come. Number 4. Jupiter is approximately 486 million miles away from the sun. Like the other planets in the solar system, it has an elliptical orbit, so its distance from the sun varies depending on what point it's at in its orbit around it. Right now, it's exactly 466,528,040 miles from the sun. Number 5. At its closest point in orbit, or to give it its fancy name, its perihelion, Jupiter is 460 million miles away from the sun, and at its furthest point, or aphelion, it's a whopping 508 million miles away. For context, by the way, Earth is approximately 94 million miles away from the sun, so like 5 times that. Number 6. This distance means that any light from the sun takes 43 minutes to reach Jupiter. If it were to explode, God forbid, Jupiter would have no idea for the best part of an hour. Although, it wouldn't anyway, because it's not sentient, or is it? Number 7. Because of its distance from that big ball of fire, Jupiter's path of orbit is understandably a lot bigger than ours on Earth. As such, it takes Jupiter 4,333 Earth days to orbit around the sun. Number 8. This also means that just 1 year on Jupiter is equivalent to around 12 Earth years. So on Jupiter, I'm still a toddler, and not hurtling towards the terrifying abyss that is adulthood. Number 9. Whilst it may have a long year, a day on Jupiter is shorter than that of any other planet in our star system. This is because a planetary day is determined by the length of time it takes for the planet to spin on its axis. So a single day on this giant is just 10 hours. Number 10. With some fancy maths then, a year on Jupiter is a whopping 10,460 Jovian days. That's a lot of spinning. Number 11. Probably worth mentioning at this point that the word Jovian doesn't mean cheerful and friendly, that's jovial. It actually means something relative to the planet Jupiter, and now we know. Number 12. Jupiter is the 3rd brightest object in the solar system apart from the Sun, OBS, after Venus and our Moon. The visual magnitude of Jupiter is -2.81, which means it's bright enough to be seen by the naked eye. Number 13. The temperature of Jupiter varies between its atmosphere and its core, but at the core of the planet, the temperature is believed to be around 43,000 degrees Fahrenheit. That's hotter than the surface of the Sun. Number 14. Jupiter is the largest planet in our solar system with a frankly incomprehensible surface area of 61.42 billion square kilometers. Again, for context, Earth has a surface area of 510.1 million square kilometers, so it's big. Number 15. In fact, it's so big that Jupiter could fit more than 1,300 Earths inside of it. And hey, if it wants to, it's up to Jupiter. I'm not one to judge. Number 16. As many people will tell you, size does matter, and that's great for Jups, as it has a radius of 69,911 kilometers, which means it's 11 times wider than the Earth, earning its title as a gas giant. Number 17. Don't be worried too much about its size, though, because Jupiter is actually shrinking. Because of the amount of heat that the planet radiates, Jupiter shrinks 2 centimeters every year. Can happen with old age, pal. Number 18. Jupiter has a polar radius of 66,854 kilometers. That's the distance from its center to the north and south poles. Don't think you'll find Santa and his elves there, though. Number 19. Jupiter has an equatorial radius of 71,492 kilometers, which is measured from the side of Jupiter and passing through the center. Much like Earth, the shape of Jupiter is flat. I'm kidding. Who the hell would believe that? It's actually more like a slightly squashed ball, not a perfect sphere. Number 20. Speaking of giants, Jupiter is one of 4 giants in our solar system, being followed in order of distance to the Sun by Saturn, Uranus and Neptune. Pluto isn't giant nor a proper planet, so get out of here, Pluto stands. Number 21. More specifically, Jupiter is a gas giant, much like its neighbour Saturn, whilst Uranus and Neptune are ice giants. Not like what Loki is, that's a frost giant. Number 22, As a gas giant, it might not surprise you to know that Jupiter is mostly made of gases and some liquids. It's unknown what's at the core of Jupiter and whether or not it's solid rock or a big molten ball. Number 23. Remember earlier when I mentioned Jupiter's surface area? Well, that's a bit controversial because as far as we know, Jupiter doesn't actually have a proper surface, at least not in the more solid way that we would describe it. Number 24. Percentage-wise, Jupiter is made up of about 90% hydrogen, 10% helium, and less than 1% of various other elements like methane, ammonia, and water vapor. That's actually almost identical to the composition of our Sun, so why is it a planet? Number 25. Jupiter does not have nearly enough mass to trigger a fusion reaction in its core, so it can never become a star. It would have to have at least 75 times more mass for that to trigger some kind of reaction. So we'll just have to make do with one sun in this solar system. Number 26. Jupiter's mass is approximately 1.9 times 10 to the power of 27 kilograms. Or to be specific, this absolutely disgusting number that's on screen right now. That many kilograms. It's so massive, I can't even make a joke about how many chicken nuggets it is. It's too many. Number 27. In terms of density though, Jupiter measures a mean density of 1.33 grams per cubic meter. That's just a fifth of the density of planet Earth, despite its monstrous size. So forget about what I said earlier, size isn't everything. I knew it! Number 28. The intense pressure within the atmosphere in Jupiter causes the hydrogen gas to compress into a liquid. This then means that Jupiter has an enormous ocean of liquid hydrogen, which is the biggest ocean in the solar system. Number 29. Jupiter's surface gravity is 2.4 times the surface gravity of Earth. Because of this, you would weigh 2.4 times more than your current weight on this planet on Jupiter. Number 30. To give you even more detail, Jupiter's surface gravity is roughly 24.79 meters per second. Now, I'm not good enough for science to tell you how that equates exactly, but what I can tell you is that a rocket would have to travel at around 135,000 miles per hour to leave the planet. Number 31. Jupiter also has an enormous magnetic field that extends out for approximately 3 million miles wide. That's more than 20,000 times larger than Earth's magnetic field. It's the largest object in the solar system, period. Number 32. Okay, more science, bear with me, but what did you expect? This magnetic field is called the magnetosphere, and has more than 1 million times the volume of Earth's magnetosphere. 20,000 times wider, 1 million times more voluminous. Big, basically. Very big. Number 33. Trapped inside this magnetosphere are charged particles, or protons and electrons, which form radiation belts. These particles come from Jupiter's ionized atmosphere, or ionosphere, as well as from solar winds that leak into the magnetic fields. Number 34. Even more of these come from Jupiter's volcanic moon Io, which releases a ton of sulfur dioxide gas into space where they're broken up and ionized. Number 35. This in turn causes huge fluctuations in that radiation, which causes intense auroras, the brightest in the solar system in fact. Makes our northern lights look a bit tame, to be honest. Number 36. But back to the frickin' magnets, how do they work? As Insane Clown Posse once said. Well, within that magnetosphere, there's an inner and outer magnetosphere. The inner magnetosphere is shaped like a donut, with old Jups at the centre, or the hole if you're sticking with the donut analogy. Here, the magnetosphere rotates pretty rapidly with the planet. Number 37. But then there's the outer magnetosphere. This is the bit that extends out for millions of miles. On the side of the magnetosphere that faces the sun, the shape has actually been blunted by the forces of solar winds. These winds can actually alter the size of the outer magnetosphere depending on their intensity. Number 38. Jupiter is also covered in clouds. These clouds are believed to be between 30 to 40 miles in thickness and have a bone-chilling temperature of around minus 234 degrees Fahrenheit. Number 39. These clouds are mostly made up of ammonia crystals, sulfur, and various mixtures of these, like ammonium hydrosulfide. I don't know what that is, but it sounds deadly. Number 40. These clouds give Jupiter its signature appearance of multiple stripes or bands surrounding the planet in various hues and intensities. The lighter coloured bands are called zones and show where the gases are rising, and the darker ones are called belts and show where they're sinking. Number 41. These stripes differ in appearance because of the transparency of the clouds around it. In the lighter zones, the concentration of ammonia is much higher, creating denser clouds of ammonia ice, which occur at a higher altitude, which makes them lighter. The meaning of life. It's also thought that these bands are affected by Jupiter's moons, as their gravity could be tugging at the atmosphere, much like Earth's moon affects our tides. In Jupiter's case, though, this is called a dynamical tide, where the gravitational influence of the moon or moons has a direct effect on the movement of interiors of gaseous planets, like Jupiter. Number 43. These wind movements appear as stripes because gases are hurtled around the planet at extreme speeds of hundreds of miles an hour. These winds change direction at different latitudes, and though an exact reason why is currently unknown, all those magnets and gravities and whatnot are expected to be partly responsible. Number 44. Jupiter has a sky. Weird thing to point out, I guess, but it's true. It's 44 miles deep and has cloud layers made of ammonia ice, ammonium hydrosulfide, and water ice and vapor. Chilly. Number 45. The Great Red Spot is a constant anticyclonic storm created by high pressure south of its equator. Much like the bands around Jupiter, the storm is caused by extreme wind speeds around the planet. The spot has a very, very high pressure center. Number 46. It was first discovered in 1665 by Italian astronomer Giovanni Cassini, but it can't be known for certain whether or not it's the exact same spot we see today. Mostly because it wasn't recorded again until 1830. So this could just be because they didn't take notes or they got lost, who knows. Number 47. The Great Red Spot is larger than the entire planet Earth and the largest storm in the solar system, at around 24,000 kilometers wide and